Now the topic is water mass and the types of water mass of Atlantic Ocean. The concept of water mass is borrowed from the meteorology. It's borrowed from the concept of the air mass. The concept of the air mass comes from the meteorology, but its first time plotted by the Helen Hansen in 1916. He introduced the concept of water mass through the plotting of temperature salinity curve in the ocean water of the Atlantic. Question is, what is water mass? Water mass is the volume of the water with relatively constant temperature and constant salinity is called water mass. So two attributes is very important in water mass, that is constant temperature and the constant salinity. Constant temperature and constant salinity is responsible for the constant density. The water volume with relatively constant temperature and constant salinity, is called the water mass. And these two attributes, constant salinity and constant temperature of the ocean water with a peculiar narrow range of temperature and salinity, responsible for the peculiar type of distribution of the density of the ocean water. So, distinct density zone of the ocean water is called the water mass. We can take example of water mass. Water masses of the Great Barrier Reef region. It is a water mass of the Pacific Ocean. So we can identify the water mass with the help of thermohaline line, rather T as curve. Basically, particular salinity and temperature of ocean water related to the water volume, and equal water density of ocean water is related to the water mass. Water mass is not uniformly distributed throughout the ocean water, and TS diagram helps to identify the equal density zone of ocean water. With the help of TS curve, we identify the zone of water masses. Now, the significance of water mass. Water mass is very important for the oceanic circulation and ocean currents. Okay, we are all familiar that in the cases of atmospheric phenomena, always high density zone. Suppose this is the high density zone and low density zone. There is also a flow of air from the high to low. Similarly, due to the uneven density of the water mass of the ocean water, there will be vertical and horizontal motion of the ocean currents. It's determined by the types and nature of the water mass. So, ocean current, ocean water movement is related to the water mass. Rather, mixing pattern of ocean water may be vertical and horizontal, depends on the pattern, nature and density of the water masses. Second one is the marine biodiversity. We can take an example of coral reef. Coral formation and others related biodiversity is depend on the salinity and temperature condition of ocean water and the density of ocean water. So, marine biodiversity is directly related to the water mass, nature of the water mass. Particularly in the cases of coral formation and coral related biodiversity zone is related to the water mass. Third one is the marine productivity. Here we can take an example of fishing, commercial fishing, zone of in the coast of Japan. In the coast of Japan, warm Japan current and cold Oishio current meets in the coastal zone of Japan, and two different kind of ocean current. Here two different types of air current means, one is warm and another is the cold. Cold is denser, rather heavier, and warm current is lighter. Those are the result of different density of ocean water, and those comes from the different water mass zone. So two different type of ocean current meets and responsible for the gathering of commercial fishing and Japan and its coastal region is rich in marine productivity. This is basically due to the meeting zone of two contrasting water mass zone. And last one is the sea ice formation. Sea ice formation related to the water mass and water density. We are all familiar that the saline water remains liquid below the temperature of 0 degree. It remains in liquid state. So sea ice formation in the cold Labrador current is responsible for the ice formation in coastal zone. Okay, so types of water mass and its related temperature and the saline condition, salinity content or the salt content responsible for the sea ice formation, iceberg formation in the northern and southern part of the oceans. And next one is the local climate. Local climate is plays a very important role, and water mass contributes a lot to control the local climatic condition in the coastal region. We can take an example of that. Lisbon and New York both are located in same latitude. In spite of that, Lisbon is influenced by the warm current that is less denser air masses, and New York is influenced by the cold current that is dense water masses. So water masses is very important to control the coastal climatic zone, marine biodiversity, ice formation in the sea, and cold ocean current. Water mass controls the vertical and horizontal motion of the ocean current. Those are the water masses of Atlantic Ocean water. Those are here. There are four types of upper layer of water masses. Its extent up to 500 meters from the surface of the ocean. It's 500 to 1500 meter from the surface of the ocean. This is the intermediate water masses. There are four principal type of intermediate water masses, and those are the bottom water masses is normally observed below the 300 to 400 meters below the ocean surfaces. There are four principal types of bottom layer of the ocean water masses. Okay, now straightforward go to the North Atlantic Ocean current. So North Atlantic Ocean current is segmented into the four parts. First one is the upper layer of central water. Second is the intermediate. Third is the deep overflow layer. And fourth is the bottom layer. So North Atlantic Ocean water mass is segmented into the four parts. Okay. Now, first one is the upper layer of central water. Next is intermediate layer. Next is the deep overflow layer. And last one is the bottom layer. Okay, straightforward come to the first part, that is upper layer central water mass. Upper layer, first we have to define the upper. What do you mean by upper layer? Here the depth of the ocean water from the surface to up to 500 meter. From surface to up to 500 meter is defined as a upper layer. So upper layer of central water masses of Atlantic is segmented into a four part. Suppose this is North America and this is South America. This is Europe, this is Mediterranean Sea and Africa. This is the Atlantic Ocean. This is A for Atlantic Ocean. So it's segmented into the four parts. Okay, this is the upper layer. Upper layer means is up to 500 meter from the topmost layer or the surface of the ocean to up to 500 meter. It's divided into the four parts. Suppose this is the equator. Suppose this is North Atlantic and North Atlantic. This is North Atlantic central water. This is North Atlantic central water. So North Atlantic segmented into the two parts. This is Eastern North Atlantic central water masses. This is Western North Atlantic central water masses. Okay, and next this is the southern part of Atlantic. So Southern Atlantic central water masses. This is Eastern South Atlantic central water masses. This is Western South Atlantic central water masses. So water masses of Atlantic divided into the four zones: North Atlantic, Eastern North Atlantic Central water masses, Western North Atlantic Central water masses, Eastern South Atlantic Central water masses, and Western South Atlantic Central water masses. Now come to the Eastern North Atlantic Central water masses. Okay, it's covered the eastern part of the mid-oceanic ridge. We are all familiar that in the North Atlantic, in the Atlantic Ocean, there is an mid-oceanic ridge in the central part of the Atlantic Ocean, just like a sine curve. So, Eastern North Atlantic central water masses lies in the eastern part of mid-oceanic ridge. It formed by the intensity of the temperature contrast extreme during the winter. That's why it's formed during the winter. The depth that it varies from topmost layer of the ocean to up to 500 meters. The salinity is relatively low in this zone. The latitudinal extension is 39 degree to 48 degree north, and longitudinal extension is 15 degree east to 25 degree east. The density of the water is 26.5 kg per cubic meter. Temperature of the ocean water is 16 degrees centigrade. The main characteristic of that water mass is that it has large potentiality of temperature and salinity range. That is the reason that is the low in nutrient content. This part of the ocean is very poor in the nutrient content. Okay, now come to the next one. Another thing is that here the density is typically linear. So when we are talking about the water masses, within the water masses zone, the density will be linear. So obviously, each and every water masses zone, there will be typical linear in TS relationship or the density. Now come to the next one, West North Atlantic Central water masses. It is also formed during the winter and formed at the southern flank of the Gulf Stream. It's related to the zone of Gulf Stream. Average density of the ocean water is 26.3 kg per cubic meter and salinity is 36.5 ppt and temperature is 18 degrees centigrade. The North Atlantic is more saline than the Northwest Atlantic due to stronger winter convectional current. The latitudinal extension is 24 degree to 37 degree north and longitudinal extension is 50 degree to 70 degree west. And salinity is high due to Gulf Stream, and it's also low in phosphate content and low in nutrient. And next one is the Eastern South Atlantic current. Eastern South Atlantic current found in the southwest coast of Africa, and it's related to the zone of Agulhas current. Here I would like to mention that water mass zone of Atlantic is related to the ocean current of the Atlantic. So it's related to the Agulhas current in the western part of the Indian Ocean. It's meet in the South Atlantic near the South Atlantic cold current and mixed with the Benguela current. Okay, it's covered the latitudinal zone of 30 degree to 40 degrees south latitude and longitudinal extension is from equator to 20 degree east. But its density of the water is 27.2 kg per cubic meter. Here the southern part of the ocean water of Atlantic is comparatively denser than the northern part. Large range of potential temperature and salinity, and it's also content low nutrient and low silicate and higher nutrient content in the few places related to the Agulhas current. And Next one is the Western South Atlantic Ocean current. Okay, this water mass is is a product of three mode of water mixing together. Three types of ocean current mixed and form that type of water masses. First is the Brazilian current with the maximum salinity. Falkland current, this is cold current, and subtropical water current. Okay, it's observed near the 30° to 45° south latitude, and longitudinal extension is 25 to 60° west. Density is near about 27 kg per cubic meter. Salinity is quietly high. It is 34.5 ppt, and TS relation is linear and also low in silicate content and low in nutrient. Okay, those are the basic four types of surface water masses of the Atlantic Ocean. Basically, northern part is less denser, but the southern part of Atlantic water masses is more denser. The diagram shows the surface water masses. This is the Atlantic Ocean, this is the Pacific Ocean, and this is the Indian Ocean. First come to the Atlantic Ocean. Here it's Europe, South Africa, South America, and North America. This is North Atlantic Ocean central water masses. That is the Eastern North Atlantic central water masses, and this is the Southern Atlantic water masses. This water masses is more denser and more saline than the northern part, and in that part, two intermediate water masses zone is observed. Okay, so you can plot that way the types of surface water masses. Now come to the intermediate layer of water masses. Intermediate layer of water masses is segmented into the four parts or four sections are Antarctica intermediate water, subarctic intermediate water, Mediterranean overflow of water, and Labrador sea water. Okay, now come to the question. What do you mean by intermediate word? This simply intermediate means is neither deep or not the surface water. It's normally start from the depth of 500 meters and its range up to the 1500 meter. Okay, it start from the 500 meter to 1500 meter. This is the normal range of the depth of the intermediate layer. Intermediate layer is potential density of the intermediate water masses is quite high. Its density ranges from 27 to 27.5 kg per cubic meter. Among the intermediate water masses of Atlantic, first one is the Antarctica intermediate water masses. This water masses is the main water masses of South Atlantic. Its origin near the South Atlantic Ocean. This water mass originates from the surface layer of North Atlantic Circumploar current, and after formation it subduct and spread northwards along the continental slope of the South America. The depth varies between 500 meter to 1200 meter. The two important characteristics of that water masses is the low salinity, low silicate concentration, and high oxygen concentration. This high oxygen concentration is responsible for the rich biodiversity in that zone. It observed in between the 40° south to 55° south latitudes. Its origin near the circumpolar zone of North Atlantic, and it submerged and flow towards south. And average depth of this ocean water masses is 500 to 1200 meters. Density is near about on an average 27 kg per cubic meter. Low salinity content and low silicate content, and comparatively high oxygen concentration. This high oxygen concentration is responsible for rich biodiversity in that ocean water zone, and average temperature of ocean water is 18 degrees centigrade. Second one is the subarctic intermediate water. It's a mixture of Atlantic subpolar and cold Labrador current. Okay, it's observed in between the 35 to 55 degree north, 55 degree west longitude and 50 degree north to 60 degree north latitude. Density on an average is quite high, that is 27.56 kg per cubic meter. Salinity is obviously low and temperature is comparatively high, that is 45 degrees centigrade. Low salinity, low silicate content, but the oxygen concentration is also high and it observed in between the depth of 500 to 1200 meter. Next one is the Mediterranean overflow of water. Here I would like to mention that Mediterranean is a bay of, or rather the salivate part or enclosed part of the Atlantic Ocean. So obviously the salinity and the temperature and the density characteristic is quite different from the rest of the Atlantic Ocean. Okay, area coverage or it covers the area is 35 to 55 degree west longitude and 50 degree north to 60 degree north latitudes. Origin near the Strait of Gibraltar. Average depth is 500 to 1200 meter. Density of the ocean water is comparatively high. It is 27.56 kg per cubic meter. And oxygen concentration is also high and temperature is also low. So it's shown as a potential for the oceanic biodiversity zone. And next one is the Labrador Sea Water. Its average depth is quite high, comparatively high, that is 1,002 meter. Average density is comparatively high. This is cold ocean current. This is cold ocean current. Cold water is more denser. So the density is comparatively high, that is 25.74 kg per cubic meter. Salinity is low, but the temperature is also low. This is due to the low ocean current and the oxygen concentration is quite high. Those are the four types of intermediate ocean current. Now come to the bottom layer of Atlantic Ocean water. The average depth is more than 400 meter and potential density is more than 27.88 kg per cubic meter. Bottom part of the water mass is highly dense and high concentration in salt and silicate, and temperature is very low, that is the cold water mass. Okay, let's have a look. This is the Atlantic Ocean. This is the mid-oceanic ridge. This is the bottom Atlantic water mass. This is very cold and dense, and this is the intermediate part. So observe the circulation pattern. North Atlantic deep water mass moves in that way, but circumpolar deep water moves in a circular way. So intermediate water masses controls the top and bottom part, or the water movement of the water masses of the upper part and the bottom part of the Atlantic Ocean. So three segment, that is the surface layer. This is the surface layer, surface water masses. This is the intermediate water masses, and this is the bottom water masses. Three are in different density. Three plays a very important role for the movement, horizontal and vertical movement of ocean water as well as the ocean current. Okay, now come to the types of bottom layer of water masses, that is Antarctic bottom water, Northeast Atlantic bottom water, Circumpolar deep water, Weddell Sea bottom water. Weddell is the name of a place in the Southern Sea. Okay. Okay, now come to the Antarctic bottom water. Okay, Antarctic bottom water, it's observed both in northern and the southern part of the Atlantic in the adjacent zone of the mid-oceanic ridge. Okay, it's observed below the 400 meter depth of 400 meter near the western part of the mid-oceanic ridge of the Atlantic. Here the thermohaline circulation is very important. Here the temperature and salinity characteristic is unique in that zone. Its latitude, it's observed near about the 63 degrees southern latitude, and average density is 28.27 kg per cubic meter. Okay, and this water mass is rich in high silicate and high salt content. Here I like to mention that bottom water masses is very cold, high in silicate concentration, and also high in salt concentration. Next one is the Northeast Atlantic bottom water masses. It found below the depth of 400 meter in the eastern part of the North Atlantic. Okay, here the average temperature is 18 degrees centigrade to 19.5 degrees centigrade, and this zone is low salinity. Comparatively, salinity is low, and the mixing of water masses and equator and Labrador current is responsible for the formation of Northeast Atlantic bottom water masses. Two water plays dominant role, that is the Labrador cold current and equatorial warm current. Average temperature of that ocean water is near about 1 degree centigrade, and its salinity is comparatively high, that is 34.88 ppt. So this is the very denser part of the Atlantic Ocean. Okay, next one is the circumpolar deep water or warm deep water. Okay, normally it observed between the 55 to 65 degree south latitude and 60 degree western longitude. Density is comparatively high, 27.8 kg per cubic meter, and temperature is comparatively low, 0 to 1 degree centigrade. High nutrient concentration, silica and phosphate concentration is also high, but the oxygen concentration is comparatively low, higher in salinity. The average depth of the Weddell Sea bottom water masses is normally more than the 3,000 meter, and it's observed in the boundary between the 55 to 65 degrees south latitudes, and its O2 concentration is comparatively high. It is the colder water masses of the Atlantic. Temperature is below the 0 degree centigrade and high concentration in the silicate. In brief, suppose this is the ocean surface, topmost layer of the ocean, and the bottom part of the ocean is not rich in oxygen concentration. Rather, oxygen concentration is low in bottom part and the lower part. Oxygen concentration is high in the intermediate zone, but the nutrient concentration, that is silicates, minerals, phosphate concentration is high in the lower part, but those are nutrient content low in the intermediate and the upper part. Okay, so all these things related to water mass solely depend on the salinity and the temperature characteristic of ocean water, that is defined by the TS diagram. And water masses is the zone of uniform density of the ocean waters. That uniform density of the ocean water is responsible for the horizontal vertical movement of the ocean water.